As promised, here's a brief explanation on how to set a custom fan curve in, EVGA Precision. The first thing to do is tick Fan Curve Control, select Custom Preset, and link all fan curves, unless you want a different curve for each of your fans. Maybe you want a card that features the now infamously hot GDDR6X. Thus, you might set the first fan to spin faster than the other two, in order to reduce heat stagnation in that area. However, my card only features GDDR6. Also, I truly hate asymmetry, so they always stay linked. Fan speed update period is, as its name suggests, the interval between two consecutive refreshes of the fan speed value. As an example, let's consider this simple curve with 0% fan speed at a temp below 35 degrees, aka the cutoff, and 40% fan speed at a temp equal to or above 35 degrees, aka, again, the cutoff. If my polling rate is 5000 milliseconds, something like this could happen. At T0 of 0 milliseconds, my temperature is 34 degrees. An update occurs and the fan speed is 0%. At T1 of 2500 milliseconds, my temperature is 35 degrees. There's no update, and so the fan speed is still 0%. At T2 of 5000 milliseconds, my temperature is 36 degrees. An update occurs and the fan speed is finally 40%. On the other hand, if my polling rate is 2500 milliseconds, at T0 of 0 milliseconds my temperature is 34 degrees. An update occurs and the fan speed is 0%. At T1 of 2500 milliseconds, my temperature is 35 degrees. An update now occurs, and so the fan speed is already 40%. At T2 of 5000 milliseconds, my temperature is 36 degrees. An update occurs, and the fan speed remains 40%. Why should I want a longer fan speed update period, you may ask? Well, if your graphics card temperature momentarily reaches or rises above the cutoff of 35 degrees and then goes down, a longer reaction time prevents the fans from spinning faster without need. Likewise, if your graphics card temperature momentarily drops below the cutoff of 35 degrees and then goes up, a longer reaction time prevents the fans from spinning slower without need. In my opinion, a reasonable value is indeed 5000 milliseconds, but you can type any number you prefer between 100 and 60,000 milliseconds. Temperature hysteresis sounds unfathomable on paper, but in practice it's quite easy to understand its behavior. Again, let's take my simple curve as a demonstration. If I set its value to 0 degrees, the fans will turn on at 35 degrees, and they will turn off as soon as the temperature decreases to 34 degrees. Then back on at 35 some seconds later. Watch this. If I set its value to 5 degrees, the fans will turn on at 35 degrees, but they won't turn off until a temperature of 29 degrees, namely 34 minus 5, is ultimately reached. Watch this. As you've just seen, this value only works as a negative and not as a positive one. If it had worked in both directions, the fans would have turned on at 40 degrees, namely 35 plus 5, and off at 29 degrees, namely 34 minus 5. But clearly that didn't happen. Now, why should you desire higher temperature hysteresis? The answer is apparent. It averts sudden fluctuations in fan speed when your graphics card temperature floats around cutoff points. For example, at stock condition and with just the right amount of a slightly variable load, my card was switching its fans on and off, on and off, on and off. The resulting noise was truly annoying. Therefore, I applied a value of 5 degrees, but you can set any number you like between 1 and 15 degrees. Now you know that fan speed update period and temperature hysteresis are powerful tools which complement each other very well. But there's a catch. While the first option works with both stepped and sloped curves, the second one only works with stepped curves. I can show it easily. This is a stepped curve. The fan speed will jump from 30% to 50% about 5 seconds after the temperature rises to 35 degrees, and from 50% to 30% about 5 seconds after it drops to 29 degrees. Watch. Polling rate and hysteresis both operate. Double-click the background to switch curve shape. Even if this is technically a stepped curve too, Precision treats it like a sloped one. The fan speed will jump from 30% to 50% about 5 seconds after the temperature rises to 35 degrees, and from 50% to 30% about 5 seconds after it drops to 34 degrees. Watch. Polling rate operates, but hysteresis does not. Oh, one last thing. You can have a maximum of 8 cutoff points in your curve. Click on the purple line to add them, and press del to remove them. Finally, let's move on to the fan curves I use if you want to take them as inspiration. This is the one active while performing less graphically intensive tasks, like browsing the web, watching movies, you know, the usual things. And this is the one active while performing more graphically intensive tasks, like rendering videos, playing video games, and running benchmarks. I'm using the same curve for each of my 4 undervolting profiles. Talking about games, in my next video we are going to fix a relatively common crash in Remedy's control, and exploit this occasion to find out which of your Ryzen cores are the best ones. Farewell for now.